in front of you Dr. Shyam Singh, Associate Professor, Chandigarh Engineering College, London. So today we discuss about Ruby laser. What is Ruby laser? But before we start the Ruby laser, we have to knowledge about the components of laser. So what is the main components of laser? Actually, there are three main components of laser. First is active medium, and then pumping, and then optical resonator. Active medium is that medium in which all the action will take place in the active medium. Like this picture, we can understand on this picture. This is the active medium. All the action achieved in this medium. So this is our active medium and energy source. In case there is no energy, then it will not process. So pumping is most compulsory. Without pumping, it is not possible. So that is pumping energy source. We can say that energy source or pumping. When we provide the energy, then there is we achieve the population inversion. Main use of this pumping is population to achieve the population inversion. And third one is activity, second is pumping, and third one is resonance cavity. So this resonance cavity actually two mirrors opposite side, one this side and one this side. One is completely silver and another is partially silver. So these are the three main components, and these are the three main components. And after that, we have also important the knowledge of level of lasers. So there are 2 level laser, 3 level laser, 4 level laser. Actually, only semiconductor laser is the 2 level laser, and other is the 3 level laser and 4 level laser. So first of all, we discuss the 3 level of laser. Let us consider E1 is the ground state, and this is E2 is the microscopic state, and E3 is the excited state. So this is the case of 3 level laser. In this case, here is the electron in the ground state. When we provide the energy by sourcing pumping or another source light, so the electron molecule go in the highest energy state, that is E3. So when the electron or atoms or molecules in the high energy state, they come back first transition in the case of high energy state, that is known as stimulated emission, and there is no laser action in this state, and the time period of this state is 10 raised to power minus 6 to 7 seconds. Okay, that is very less time as compared to the metastable state. There is time approximately 10 raised to power minus 3 seconds, and there is a laser action, and the laser action takes place in this state. So this is the 3 level laser. Actually, here we have also the transition from 1 to 3, 1 state to 3. When we provide the energy, electron or atom go from 1 state to third state in higher energy state due to pumping. And there is spontaneous emission in this case. The spontaneous emission actually in the higher energy state occur the spontaneous emission, and the time period is very small, as we say that 10 raised to power minus 7 to 8 seconds, and there is no laser action. And the some atoms or electron reaches the E2 state, that is metastable state, and the metastable state, and there is a population inversion between the state 2 to 1, and the laser action takes place in this state, and that is known as stimulated emission. So this is the 3 level laser. And now we see here 2 level laser, 3 level laser, and 4 level laser. So 2 level laser only 2 state. First state and second state. There is no action, laser action takes place. Okay, this is the laser action takes place only in the case of semiconductor laser. Okay, so in this case, 3 level laser we discussed in the last slide, and this is the 4 levels laser. So this is the, let us consider E1, E2, E3, E4. E1 ground state, E2 next higher state, and this is upper high state. This is the last higher state. This is the 4 level state. So in this case, in the high energy state, first K is in this case, and there is no no laser action takes place in this state, and the atoms or molecule reach in this state, then there is a laser action takes place. We can say that laser transition is in this state, and the other atoms or molecule reach here, that will come back in the ground state. This process typically when this already done. So atom again this and again pumping, atom come back, again pumping, atom come back. So this is the second 2 level state, 3 level state and 4 level state. So here we learn about first of all 3 main components of laser, and after that 3 level of laser, 2 level of laser and 4 level of laser. Now we start ruby laser. So first of all, what is ruby laser and what is the application of it, and what is the working model of the ruby laser. So first of all, we can see that it discovered by T.H. Mammon in 1960. This is the first laser and it is a solid state laser. There are so many types of laser like helium laser and carbon oxide laser and divided laser, so many lasers. So this is the first laser that discovered by T.H. Mammon in 1960, and this is a solid state laser. Only this one is the solid state laser. Other laser is gas laser and semiconductor laser, diode laser, so many. Okay, so this laser is the outcoming of this laser is mainly cavity consistent of pulses. Cavity consistent of pulses separated by a small interval. So we can say that it is a pulse based laser, and the wavelength of this laser is 694.3 nanometer. In case we change it in angstrom, then it will become 6943 angstrom. So next, construction of the ruby laser. Very interesting ruby laser. We have used the ruby rod that is made by aluminum oxide and chromium oxide, Al2O3. We have used the ruby rod that is made by aluminum oxide, Al2O3, and the amount of the chromium ion we use approximately 0.05%. That is very small amount quantity. Chromium, we have chromium ion, very small amount of quantity, that is 0.05%. And these chromium ions are responsible for laser action due to chromium ruby rod. Looks like due to chromium ruby rod, and its color looks like pinkish. Okay, and the ruby rod crystal is about the length of the ruby rod is approximately 0.6 centimeter in diameter and 4 centimeter in length. Very small, 0.6 diameter and 4 centimeter in the length. Both ends of the ruby rod is polished and silvered. One end of the rod is fully silvered and another is partially silvered. So next, the source in this case, as we discussed in starting, without source or pumping, it is impossible to achieve the population inversion. So in the case of ruby laser, we have used the pumping. So in the case of here, we use the flash tube for pumping. We use the flash tube as the energy source or pumping source, and the flash tube lasts several million seconds, so that we achieve the population inversion. Optical resonator. The two ends of the cylindrical ruby rod are flat and parallel. Optical resonator we also discussed in the starting in the main components of laser. Actually, optical are two flat. We can say that the lenses may be convex or other. One side is fully silvered and another is partially silvered. At one end of the rod, the mirror is fully silvered and another is partially silvered. The fully silvered mirror will be completely reflected the light, whereas the partially silvered mirror will reflect most part of the light, but allow a portion of light to pass as the output laser light. In the case of partially silvered, there is output of the laser light. So the reason that one is fully circular and another is partially circular. And the optical pumping result when incident photon of the wavelength approximately 500 angstrom raise the chromium ions from the ground state to E1 to higher energy state E3. So this is the energy provided by pumping to excite the electron from ground state to high energy state. So this is the diagram, and this is the ruby rod. This is the ruby rod, and this is the flash helical cylindrically flash tube. So the ruby laser is a three-level laser, as we discussed. In this laser, optical pumping done by the helical xenon tube. Helical xenon tube. This is the helical xenon flash tube. And which provides energy to the atom, raise the electron from low energy state to higher energy state. Why this xenon tube? We raise the electron from low energy state to higher energy state. So this is the energy diagram of the ruby laser. So here is the ground state. Ground state, we can also say that it is E1 ground state, and this is the E2 state. E2 state is metastable state. That is also high energy state. And this is the most high energy state. We can say that E3. So the time period of the E3 is high energy state is when small time is to power minus 7 to 8 seconds, and this is the radiation less transition because this is after a spontaneous emission, and we know that in the case of spontaneous emission that is transition less. And there is no laser action takes place. And when the atom or molecule come back in the metastable state, they are much more, we can say that here we achieve the population inversion. And there is a laser action takes place. And the value of the laser action wavelength is 6943 angstrom. So this is the energy diagram. Here we also write. Let us consider the laser medium consisting of three levels E1 to E1, E2, E3. The energy level E1 known as ground state, and another is E2 metastable. This is the E3 state. And initially all the electrons in the lower energy state. When we provide the energy by xenon flash tube, in this case atoms go in the higher energy state. Atoms start from there and reach in the higher energy state. The time period of this is small, and some of the atoms go here and there. There is spontaneous emission, and some of them come back here, and there is metastable state, and there is we achieve the population inversion, and then here we achieve the transition, laser transition. So this is the energy diagram, and this is also some point when how it works from E1 to E2 and E3, and E3 to come back into, and E2, E1, and the laser action takes place. So we can say that this number of electrons in the metastable state E2 increase, and hence population inversion achieved. And the stimulated transition of chromium ions from metastable state E2 ground state and E1 is known as the laser transition. So this is all the process E1 to E2 and E3, and come back E3 to E2 and E1, and we get the wavelength 6943 angstrom. So application of the mainly ruby laser, there are so many applications. First one, optical pumping, Raman spectroscopy, holography, and material processing. In the case of optical pumping, we used to study the principle of quantum mechanics and the behavior of the atom under various conditions. Quantum mechanics we can use, and also we find the behavior of the atom under various conditions, what type of atoms and what is the process of the atom. And another is Raman spectroscopy. Raman spectroscopy reanalyzing the material properties while observing the vibrational, rotational, and other low frequency modes in the system. So this is a good application, Raman spectroscopy, because it is very difficult to find the vibrational, rotational, and other low frequency modes. So we can use with the help of this. So holography, ruby laser holography for creating high quality holographic images and their coherence, monochromatic light or interference pattern in the holography. So it is also the application. And next one is material processing. Due to their high peak power, ruby lasers are also utilized in drilling, cutting and welding of material including metals and polymers. So these are the applications of ruby lasers. So thanks.